we are live on YouTube. Hello, everyone. And yeah, it's my pleasure today to learn something new again, like we all tried on a weekly basis. And today we want to talk about Talos, which I heard is a Kubernetes operating system. But yeah, I'm eager to learn. So it's my pleasure that Andrew joins us from Talos, and he will do an introduction, share us the cool stuff. We do a live demo, whatever comes to mind. Yeah, and with that, I would just like hand it over to you, do a short introduction, and let's get it going.
My name's Andrew Reinhard. I created Talos, roughly 5 years ago. It started as a project where I was managing a bunch of Kubernetes clusters, and I was very frustrated with having to manage both the OS and Kubernetes itself, and so started working on Talos. I was very inspired by a project called Linux from scratch. It was also kind of like a learning experience as well, just building an entire Linux distribution completely from the ground up. But I wanted to build it for Kubernetes specifically. Fast forward a little bit, and I founded a company roughly 2 years ago, April 2019. And since then, we've picked up a lot of pace, and we're kind of building on top of this OS, even management tools for Kubernetes clusters, say on-prem, across VMs, in the cloud, whatever. And just building out the operating system for Kubernetes to make it more secure, more reliable, so on and so forth. I'll get into the details. So yeah. Should I share my screen now? I have a couple slides.
Yeah, just go ahead. You can share your screen. We can dive into the more we can like explore together, the better, I would say.
Cool. Sounds good to me. So let me first of all do this, because this will. Oops. I want to present. So I stole these slides from another thing. So yeah, again, just talking about Talos. I want to briefly talk about what it is. I like to start with a little bit of the origin story. Again, I talked about this in my intro. I was managing a bunch of Kubernetes clusters, and I found that for everything at the OS that I had to do, such as securing users, doing patch management, installing the OS, so on and so forth, there was parallels within the Kubernetes world. And so, at the time, and I think this is still a problem within our industry, is that there's not a whole lot of Kubernetes expertise out there. So this job fell onto the shoulders of the operations engineers. They had to both figure out how to wrangle Kubernetes and to continue maintaining the underlying OS. And, for one person migrating a bunch of applications, it was a lot for me personally. Just making sure that both were monitored, so on and so forth. And so I thought to myself, what if I could just kind of more or less eliminate the operating system? What if there were no users? What if there were no SSH? And so that's kind of where Talos was born, is coming from this place of, let's actually get rid of the OS as much as we can. And even on top of that, just let's bring in, modern things like latest kernel, latest version of IP tables, so on and so forth, but still staying minimal, but also being able to bring the latest and greatest features, particularly in the kernel. And so that kind of evolved from there. It started off with, okay, I have a rootfs and it just runs the kubelet. But now I have no SSH, I have no bash, I have no way of inspecting when things go wrong. And believe me, they went wrong in the very early stages. Why is the kubelet not running, so on and so forth? And so I said, okay, well, I don't want SSH. I don't want people hopping onto a machine and making this one a snowflake versus that one a snowflake. So let me do a couple things. Let me actually put an API. I'll have an API. I decided to make it gRPC. And this API is going to give me diagnostics toolings that I might need when the node is up. Instead of SSHing on, I just hit an endpoint and I can get data, which processes are running, so on and so forth. And I also want to encourage that even if someone does manage to get onto the operating system, I don't want snowflakes. You know, in a clustered environment, you need your substrate to be as consistent as possible. And so let's make the rootfs read-only. It went through a couple iterations. It was mounted as read-only and it was an XFS file system. But today, currently, Talos is delivered as a simple squashfs. And I think it's roughly around, I want to say 50 or 40 megabyte squashfs. That's the entirety of Talos. And so it can't be remounted as read-write. So it's all or nothing. It is read-only, and that's that. And again, keeping it as minimal as possible. Talos just comes with the bare minimum that you need to run Kubernetes, more specifically the kubelet. So that comes with containerd, IP tables, oh God, not a whole lot else. It's really that we deliver the kubelet as a container. There's a lot that the kubelet does depend on, but that's in the container of the kubelet itself. I was going to go there. So yeah, the idea is that basically we're going to modernize the OS for distributed systems. And another thing that I think is interesting in practice, what this means is that we actually don't even run systemd. It's a completely new init system, which we're calling machined, which is built for the purposes of these distributed systems types things, right? It comes with an API. It's completely written in a modern language. It's Go. And so what that translates into today is really the Talos is almost a single binary. I think we have one extra service that we call trustd that runs right now, and it runs as a container outside of Kubernetes. But other than that, Talos is basically a single binary. I lied. There's also udevd. We tried to rewrite udevd in Go, but that was no fun. Maybe we'll pick it up again later. So the idea is that, you know, if you were to hit the Talos list API and look at the rootfs, you would see that there's actually not a whole lot outside of Kubernetes. And again, another thing to point out here is that there's no SSH and there's no shell. So the next thing I want to talk about is something that we're trying to do with Talos is we're really trying to ask ourselves, you know, what is this API driven operating system? How can we standardize that? And how can we bring this to the world in a more generic way, in the same way that there's the container networking interface, the CRI, the container storage interface, so on and so forth. We envision a world where there will be an API for things like Kubernetes to communicate with the host. So today, the way that currently is done is the kubelet just forks out or shells out to commands like the mount command, so on and so forth. And sometimes if you don't have those, that's why we run Talos in the kubelet in a container, is because we have to make sure that those things are there, but they can't be on Talos. The idea is that we want to provide an API for even things like container network interface to speak to the host operating system and say, create IP tables rules, so on and so forth. And so we're coming out with this idea that we're calling currently the Common Operating System Interface. It's likely to change because COSI, C-O-S-I, the acronym is already taken in the CNCF landscape. So we got to figure out something else. But the idea is, again, we want to come from this place of, you know, your traditional operating systems. You can see on the left here, your traditional Unix systems are really oriented for a single shared system, right? Multiple users hopping on and managing it, multiple users having to be created, so on and so forth. In our world of COSI, we envision a place where the host really just has one job, and that is to deliver isolated workloads, VMs, containers. And so this is probably not in the correct order that I want to go in. Let me jump down to the shell. So we've taken out the shell. And what that means is in practice, there's no users, right? It's just purely API driven. And so how do you hop on and make things happen? The idea with Cozy is that everything's going to be declaratively driven in the same way that Kubernetes is declaratively driven. So if you want an interface configured, you're going to have a YAML file that represents how this interface should be configured. Say bond 0 needs to be set up in such and such a way. You deliver that to the system, and you're going to have a controller that lives on the operating system that makes that a reality. That's your new way of interacting with the system, not hopping on and using pipes. These are plugins, as we're calling them. Plugins can kind of represent something bigger, like, for example, in Talos 011, as we're going to show off today, we have a plugin it's basically a whole new networking stack. And within that networking stack, it has controllers for a bunch of different resources like addresses and routes and so on and so forth. I'll show you in the demo. But that's the new way of doing things within this world that we see. We're going to bring the idea of controllers down to the operating system itself, and they are the ones that are in charge of enforcing the state that you define declaratively. And one of the benefits to this is that now the entire system is under a structured configuration format. So nothing is now an Ansible playbook that SSHs onto a machine, runs this command, pipes it through grep, pipes it through awk, so on and so forth, which can change and break from different versions. It is a API that has backwards compatibility guarantees, and you submit YAMLs that make this a reality for you. I hope that was clear. I'm happy to pause and take any questions. And that's kind of setting the stage for the demo.
If you if you say controllers, I, as an engineer, would imagine like the same control loops Kubernetes provide. Is it like the idea behind?
Yeah, exactly. So the idea is that you could go and write a plugin. This is not currently possible today. This is just kind of, setting the vision right now. We do have this idea within Talos currently. It's our networking stack. But the idea is, yes, you will be able to get notified when someone creates something that you want to be notified about, updates, deletes, changes, so on and so forth. You have a reconciliation loop that gets hit, and you are now responsible for enforcing what the state should be based on your inputs and outputs. The previous way that we did inputs and outputs as engineers was, again, we would SSH onto a box, we'd run a bunch of Unix commands and pipe them through a bunch of things. In the Cozy world, it's very much like Kubernetes. You set up subscriptions to be told when you say an interface is created by the kernel, or someone sets up a firewall rule. I'm creating that gets sent to you, and maybe you want to make decisions based on that, and you have a different output. Say it's something else. It could be, maybe overriding those firewall, but it could be arbitrary. Just imagine what you want. The inputs and outputs are now different. They're not free form, they're structured, and they're controllers that are actually taking inputs and making things happen per a spec that has been delivered to it.
Yeah, I mean, I watched your KubeCon talk about Cozy, I think. Yeah, I'm sad that the name has to change, because Cozy was a really nice name.
I like it.
Yeah, I mean, I like the vision and the idea, because, yeah, today nobody wants to SSH anymore to a server. So,
yeah, I honestly don't think we should be, especially in a distributed environment like Kubernetes, right? And when you give it's just too tempting. Even as a senior engineer, sometimes you have a problem and it needs to be fixed, and you hop on, hey, look, to stop the bleeding, I had to do X, Y, and Z. And sometimes that's not communicated. And then now this machine is a snowflake. And so it's really just embracing and enforcing this idea of, pets, pets versus cattle. And the problem that I found was that, you could easily shame somebody on your team and say, hey, you shouldn't be SSHing in and doing that. But anytime you have those social enforcements, they're very weak, and they cause tension within the team, because sometimes you got to do what you got to do. And look, I fixed it, but then it just creates this dynamic that's not very conducive to a well-performing team. And so now with Talos and something like Cozy, you're actually fighting the technology, right? You're fighting a robot, and you can be mad at that robot that says you cannot do that because it's a read-only file system. Be mad at that, not your teammate. And so it really, at a technological level, really enforces this idea of immutable infrastructure, because in the past, right, we've had golden images, and we've said that you shouldn't SSH onto them. And I've seen some people even say, okay, once it's SSH into, it's automatically marked as invalid and taken out of the loop, and so on and so forth. But that's a lot of things that you have to take care of. And so where Talos kind of delivers is, first of all, you just simply cannot do that from a technological standpoint, and it's conveniently packaged. You don't have to go and build golden images, all these things. This is just an inherent idea built into the operating system, and you get all of that goodness. It's all delivered by the team upstream.
Yeah, I'm totally with you. I mean, also, it's often like politics, like, oh my God, I was 10 years engineer with SSH and I need SSH. it's like my air,
Yeah.
But in the world, like as you said, is moving more and more to APIs. So why should we SSH?
Yeah, exactly. I'm actually very surprised. That was a fear that I had. I remember us going to our first KubeCon, and I was like, man, we're going to tell people that there's no SSH, and they're going to turn around and walk away. And they actually leaned over the desk and, wait, there's no SSH. I love that idea. And so, yeah, I think the industry is definitely ready for this. So yeah, I can hop into a demo and start putting some concrete things behind these ideas and showing off if some of the things we've done in 0.11 if you want.
The thing is, like, I didn't even know if Michi SSH ever into a server. So for him, nothing will change.
Well, I do use SSH, but if there is a different method for it, I'm all for it. So I know the shortcomings of, I think yesterday or 2 days ago, I advised the user to not set a password on the Git user for SSH, just because it's a security vulnerability or possible attack vector. So not using SSH is a good idea in various scenarios.
Right.
I mean, practically from let's say our day job is like this. For example, you do some Terraform infrastructure as code, then you have your Kubernetes cluster and your SSH keys, and then a new member joins, and then you always struggle and make SSH keys new and rerun your Terraform state. So it's really annoying.
Yeah.
So
yeah, and then 9 times out of 10, that same user needs permissions within Kubernetes even, right? And so they have different roles based on where they're operating. With the API, we have this vision of kind of unifying, using Kubernetes RBAC even to define what APIs you have access to within Talos itself.
And I think from a user perspective, I don't need SSH access to most servers, and at GitLab I don't have it, so I cannot break anything. But I also cannot like look into the stuff. I need an abstracted way, and then I get an API and maybe an event stream or something like that, where I can see what I need. And most oftentimes, when I'm debugging something or when I want to change something, I need a scoped view. But I don't want to like search it myself. And okay, I can do that totally on a server on the terminal. But in the end, it would be much more nicer to have an API, have a web interface maybe, and automate everything.
That's exactly it. It's I always ask people, the people that do say, well, I need SSH. I'm like, well, what is it that you want to get? Well, I got to hop on and figure out what's going wrong. Well, what if there's an API that can tell you what's going wrong? You could do the same things over an API. Oh, okay. Yeah. So it's really not about SSH, the technology itself. I mean, maybe there's some people out there that really love SSH and they think, why are these people reinventing the wheel? But the API really, if you get those debugging tools, that's really what you want, right?
Definitely. And I think now it's time for a demo to see something.
Yes. Let's start off with something simple. You mentioned a UI. This is like a simple TUI based thing.
Nice.
I can show a
This
UI.
is-
But the interesting thing about this is I just ran a command called Talo Ctl Dashboard, and this is running. And tell me if I need to blow this up. Is this too small?
It's fine.
Okay. I'm running this from my local workstation, and this is a Kubernetes cluster that's running Talos in our data center. And this, all these little pieces like, CPU, memory, the processes list, load average, all of these little components here, they're all individual APIs that we're kind of in Go, we're kicking off as Go routines, and we're aggregating this data and we're refreshing this screen as we go. And so this is all API driven at the end of the day. And I can cycle through at the bottom here. I could say, look at different machines. And I could even, exit out of this and let's take a look at a list of processes, for example. Notice that it's prefixed here. This is kind of a lot. Oh, that is ugly. Notice that it's prefixed here. Let me go this. This looks better still. In the front here, I want to point out something that's kind of interesting is we're able to aggregate this data. So the way that this roughly works is I have within my configuration file right now, I'm telling Talos Ctl that I want to talk to three different nodes. I want to talk to CP0, 1, and 2. And I want to ask them for a list of their processes. And so you submit this request to a control plane node within Talos, and it goes off and it makes this request on your behalf to those nodes, aggregates that data, and gets it sent back. So for example, where this can be really useful, sometimes I use this a lot, is say, looking at the logs of etcd. Sometimes, you have 3 different terminals open. You're trying to figure out what one etcd thinks versus another. You can see all of them here. CP0, well, let me scroll way up. Here's CP2. This is an aggregate of the logs of all the etcd services that are running within the cluster. Talos-Ctl services. I can get a list of all the services that are running. Again, we run a minimal number of things. So this is probably a chance to show off really the entirety of the services that run on an a Talos node. We have APID, which is the front end. Basically, it's the connection. It's the thing that has an exposed port that actually serves the API on each machine. We have containerd. That is the only CRI that we offer currently. Sorry, I should clarify. We have containerd because we do run one service here called trustd in a different instance of containerd, which is backed by ephemeral storage. So it's completely running out of RAM. And trustd provides sort of the PKI automation within a Talos cluster. And then we have the CRI itself, which is just another instance of containerd, but it's just serving the purposes of the CRI within Kubernetes. And obviously, this is a control plane node, so we're running etcd and the kubelet. So this is kind of an older way of doing things within Talos. We had very specific endpoints, APIs for very specific things. You saw me talk about this thing called the Common Operating System Interface, and it looks and feels very much like Kubernetes in that there's, CRUD operations you can get, so on and so forth. So let me just show you the same thing, but now I'm doing Talos-Ctl get services. This is just a single endpoint within the cozy world, but you're telling it what kind of resource that you want. And this is the model that we're going towards more for Talos in the future. And in 0.1.1, we've completely rewritten the networking stack to be based on top of the Common Operating System Interface. Just to show you, I can actually show you, there's an alias here too, but I wanted to be explicit here for you guys to see. Let me show one node for now. I'm going to show you the resource definitions. These are almost like CRDs within Kubernetes that the node CP0 knows of. These are all the registered sort of, imagine them as CRDs again. We have address specs, address statuses, link specs, link statuses. I'm going to just look for all the networking specific things. resolver specs. So these are resources. So let me just show you what I mean. Get addresses -o YAML. So you can see that I have a bunch of addresses. Actually, let me show you it without the YAML first. Here's just the table view. Here's all the addresses that I have on this particular machine. Now, outputting them in YAML, you can see that these are very much like Kubernetes. Here's the node that this is on. Here's the metadata. It's in the namespace, the network namespace. We plan on having, default APIs in the cozy world. This is just the unique identifier. That's just the, which interface and the actual address. And then specifics around that, right? Which family it is, scopes, so on and so forth. And the idea is where we're kind of moving with this is today, Talos has a single configuration file, which basically, let's see. Let me put this in YAML. It has a single configuration file where all of these things are kind of like the machine, for example. The networking is kind of it's just a single thing, right? And it's got interfaces, it's got a host name, it's got a list of name servers, it's got a list of, time servers, so on and so forth, different ways that you can configure the networking for this particular node. But it's a single thing. It's a single control YAML. And the direction that we're heading is that we want to actually look at these things like multi-doc YAMLs. If you need to configure an interface, you just set up an interface that targets, bond 0, and you apply that to the system. So let me talk about a little bit, and feel free to say, hey, slow down, I have a question, or can you talk about something more? I'm kind of just going.
We have just one question from the audience on YouTube from Noel. Hi, Noel. He asked, what happens if RPD crashes? Is there any, can you say, okay, first one question, what happens if RPD crashes?
Yes, so if APID crashes, the answer is the same thing as if SSHD crashes. You don't have access to the node anymore. But okay, this is not unparalleled within our, it's same problem that you would face with SSHD.
But is there any control loop which would restart it?
Yes, absolutely. Okay. So machine D is PID 1. Again, we don't use systemd. It's our PID 1 is machine D, and it will make sure that this service tries to always be ran.
Perfect. But if SSHD stops, then it does restart on the systemd. So
it doesn't?
I don't think so. If on systemd your service crashes, it just doesn't restart. That's why we need all Kubernetes, because it takes care of. And the question is there something like supported to sending APD logs or any logs from Talos to another third party like Loki or I don't know, Elasticsearch, so that you can debug what happened in the Talos control plane?
Yeah, that's a great question. Currently, all the logs are stored within an in-memory buffer, and we don't write anything to disk. This is a problem that we need to figure out. The idea is that we could write. The idea that we have is that we could write, say, a plugin or something within Kubernetes, a daemon set or something that actually can have access to the Talos APIs. Again, we're trying to find out how to bridge service accounts with the Talos API. But the vision is that you'd be able to maybe write something that can just get the logs of all these things and ship them off and put them into whatever format that you want, whether it's writing them to disk or shipping them directly to, FluentD or whatever you want. But currently that is a little bit of a problem.
Yeah, but we are at 011, so all good, I guess.
Exactly. We we still have some progress. Talos is still we feel it's production ready.
Could you like, so you could run PromptTail as a daemon set correctly, but you need to figure out the access to the Talos API. That's more the issue, right? Yeah. Okay.
Yes, exactly.
Yeah, I would have another question, like for me,
Sure.
like when you, for example, often when you run Kubernetes, you need some certificate like the etcd PKI certificates, the key, and so on. So in Kubernetes, maybe you would copy it, or you can mount the host path, and then you have access to the certificates. How would you do it in Talos, for example, to monitor etcd with TLS?
Yes. So the etcd certificates are written to disk because we have to mount those up into the etcd container. And so there is a way to do it. That being said, we are trying to figure out how to actually prevent people from getting onto the host. Because again, security is another big emphasis within the Talos project, is that we, because there's things that, container storage interfaces and CNIs do. And the one that keeps popping up is a lot of them want to NS enter into PID1, get into the root host, space, and actually execute different binaries like mount or iSCSI, ADM, or, all these different things. And we are not big fans of that. We don't think that that's the way to go. We don't think mounting up host paths is a way to go. So we do have Talos, like we do have APIs like what's it called? I don't remember the name of it. There are etcd specific APIs. So, it could be possible that maybe we provide those. Just as an example.
I mean, from practical, it's like always the issue to monitor like etcd, because you can only authenticate with certificates. They are not externally exposed.
Yeah.
So
currently, you're saying the way that you're doing it today could work with Talos. They're in Etsy Kubernetes, PKI, etcd, and you just mount that up and you're good to go.
So that's the small part of Talos which is persisted, as you said, right? The rest is more like immutable.
Yeah, actually, that's a good point. I don't think I actually talked about that. Again, going back to the architecture is Talos is a squash FS and it's read only. We do have we create this directory. Let me show it to you. We create this directory called /system, which is basically a temp FS, and this basically holds runtime data that's completely, reproducible on every run. But we also do have one place where things are persisted, and that is in /var. So the kubelets data is persisted, etcd's data, container D, so on and so forth. That is the only writable place. Now, that being said, when you perform an upgrade within Talos, the default way of doing an upgrade is we actually shut everything down except for PID1, unmount all mounts, and then we completely wipe the disk from underneath Talos and we reinstall it as a brand new node. It's a way to kind of do like in place pets versus cattle, this idea of like replacing a node rather than upgrading a node. Our upgrades are actually full on replaces, but they're in place, if that makes sense. And so /var, we label it as ephemeral. We tell you, yes, it is persisted across reboots, but it is not persisted across upgrades. That being said, that posed a problem for single node clusters, which we do have people running in production. So we do have a way to say preserve the data. So you have options within Talos to how you want to perform that. But yeah, that /var is the only writable place, essentially.
Okay, so basically, for example, I have a 3-node cluster, and then I will upgrade one node. Then everything will be wiped, because my question was like, how is it with the PKI when it's not persisted? I mean, you cannot add a member.
So we have one more partition that Talos saves things to, and it currently today it's called the state partition, and it just stores the configuration file, and so that is persisted. Other than that, it's not. You could tell Talos even to not save anything, or sorry, to always pull its configuration file. That is also an option.
Okay. Like from Git declarative, you mean? Like
not from, well,
or,
you could store it in
from any
Git.
frame web from anywhere.
Yeah.
Okay.
Yeah, HTTP endpoint, not necessarily Git protocol, but you know, you could host it on like, you know, a GitLab instance and give tokens to Talos to say this is how you download it.
Okay, great.
So yeah, I want to just kind of show off one thing. Watch Talos Ctl Git addresses. I don't know if this is going to be big enough. Let's see. Let me actually do this.
I think you as I saw, the CNI is Cilium, right?
Yeah, on this particular node, the CNI is Cilium. Yeah, the default is Flannel.
Okay.
So I'm going to just do something simple here. And I'm going to edit our machine configuration and show you what these controllers, what the pattern really helps with in practice. So I'm going to create an interface here. We're just going to call it interface. We're going to call it dummy 0. And we're going to just say dummy true. I don't know why my editor does this. I hate it. So if I save this, that should apply. Oh, am I pointing towards the right node? Let's see. Dummy 0. Well, this is a good opportunity to show off some debugging stuff. So let's do this. We'll do Talo Ctl logs -n. We'll focus on this particular node that I just edited the configuration file for. And we have this thing called the controller runtime. This is the thing that actually tries to apply. And we'll see if it knows anything about dummy. What is it saying? Okay. What did I do wrong? Oh, we may have lost API access. So this is another opportunity to show off something. So let's do, we have this idea of endpoints. Mikhail, you said that you like things to break. So I'll give that to you.
We think it's on purpose. You did it on purpose, right?
That's right.
No, it doesn't look like that.
All right, so I probably did something wrong. I messed up the configuration file and I messed up control plane 0. So I'm actually going to tell Talos instead now. I want to get the IP address of these nodes. Where are they? Why don't I see them? Oh, there they are. So we have the notion of endpoints and nodes within the CLI. And endpoints are these things that are basically, we do client-side load balancing to put it bluntly, is basically you have a set of endpoints where the Talos CLI will try to load balance all of the API requests across. And so the endpoints should be set to all of the control plane node IPs. And then when you make a request, the list of nodes that you set are the ones that the requests are actually submitted to. So let's just do this. I'm going to actually tell Talos that I want to hit this endpoint and I want to look at the logs of that machine. So we haven't lost API necessarily. I messed up something in the configuration file, and now this machine is simply broken. I'm not quite sure how I'd recover from this, to be honest with you, but the idea with Talos is you blow it away, reinstall it, and give it the configuration file before you made whatever dumb mistake that I made. So yeah, what I was wanting to show you guys is that I was going to add a dummy interface, and it would just be created, declaratively. I'm going to say I want this interface called dummy 0, and it is a dummy interface. I want you to create it for me. It makes it happen, as opposed to hopping onto the machine with SSH, finding out which IP command you have to run and adding an interface. It's not a human doing it. You submit this to the system. The configuration file declaratively defines what you want in your networking stack, and this gets rolled out for you, essentially.
Could you edit the machine config now from the endpoint or with the endpoint IP?
It looks like I probably destroyed. Well, let's try it. I may not have.
It looks like a firewall problem because NTP cannot sync.
Oh, that's just it's kind of like when you're in Kubernetes and you get those controllers. I don't know if you guys have used the controller runtime in Kubernetes, but it has this, when you log an error, it has this like stack trace that looks really nasty and it's scary, but it's really just logs. At some point we were failing, but it's not currently failing. So I could, show you get time statuses. Oop, what did I do wrong? Oop, not logs. CP1 and CP2. So I'll get the time statuses for the 2 nodes. They are synced. We can look at the specs. Maybe it's not. What's it called? Time server specs. If we put those in YAML, we can see that our time servers are set to pool.ntp.org, and we can get the statuses saying that they are in sync. So yeah, it was just a nasty, not nasty, but it's just a log, in your typical controller pattern that says, I faced this error, but it's not currently an issue.
But the thing is, to be prepared for tomorrow's cluster session, you have to fix your node now.
Well, it's actually not Talos, so I got to dust off the old skills and see what happens. Yeah, so I messed up this machine. So here's the problem with networking. This is probably a good chance to talk about some of the things that we can see road mapping wise. Validation on the config is something that we want to do, especially, and in this case, it's very apparent around the networking stack. You can easily mess up the networking. Rolling back of that configuration if the networking goes away, something to that effect. And yeah, again, just validating settings, letting you know that this thing is not a known field, or this field is it's not a valid option. We're working towards that. We have some of that today, but we need to flesh that out a little bit more. And just general configuration management within Talos. Again, talking about the machine configuration file being one big file. We're playing with this idea of having it feel very much like Kubernetes, where you have a bunch of YAMLs that represent the config collectively. And you can submit them individually. You can submit them, multi-doc, so on and so forth. Very much like Kubernetes.
If we're talking about network, I saw something about WireGuard. So do you use WireGuard under the hood?
Yeah, that's a good question. We don't use it out of the box, but we are working on something where we're going to be able to automatically set up a WireGuard mesh network so that you can have, say, nodes running in the data center. Like our current plan is to, this particular cluster is running in our data center, and we want to be able to burst out to Equinix Metal for bigger machines that we may not have. And so we want to set up a WireGuard network across those two so that it feels like a single network. And we're working on something to make that completely automated, because with WireGuard, you got to set up your peers, you got to set up, all these different things. And we have something that we're going to be coming out with where you can do that automatically, and it'll all be driven via the configuration file for Talos, and completely automatic. So yeah, nothing out of the box, but we are working on ways to use WireGuard for these hybrid cluster scenarios.
Wow, cool. And then the last question to network, with the virtual IP, does Talos support virtual IP for the control plane, for example?
Yeah, it does. So we use etcd to just figure out who should own this IP at the time, and we set that up. In fact, I think that may be what we're doing with this particular node.
So like the etcd leader receives the virtual IP?
Exactly. Simple as that.
Oh.
Yep. It's very useful in your home environments, even VMware. Like that we have some users that were struggling to figure out how to set up a load balancer dynamically based on VM's IPs. You got to be able to have Kubernetes API be HA. They just use the virtual IP, and now you have an HA cluster, and it's really, really simple. It's a really cool feature of Talos, I think.
I have a question around, you said this is hosted in your data center.
Mm-hmm.
When I'm like a beginner with Talos, which would you recommend, like following the quick start guides, or is there something like, what is the 5-minute success story for my home environment? For
your home environment, well, let me start with even simpler than that. Let me start with local, and then I'll talk about what you could do for home environment. We do have a way with Talos. We have this command called Talo Ctl cluster create. And what this does is it actually uses Docker to create a Kubernetes cluster right there on your desktop. And it's literally the same image that you can run within your home, AWS, on-prem, wherever. And it just spins it up in Docker for you. And then you can get a Kubernetes cluster right there, Docker-based. It has a way of also running in QEMU. But if you want it on real hardware, we have an ISO. And the way that works is you boot the ISO, and then Talos comes up, and it knows that it has no configuration file. It knows that it's running an ISO, and it knows also too that Talos has not been previously installed. And so what it does is it sits there with an unsecured port. I know that sounds bad, but it sits there and it says, okay, I'm waiting for a configuration file to be pushed to me. And so it'll print this out onto the console. It'll tell you how to connect to it. You could even add a fingerprint validation for the cert if you feel like you want to secure it in some way. And you just generate the configuration file, and you push it to this initial node, and it bootstraps itself. And you have yourself a Kubernetes cluster a few minutes later.
This means I need to try it out. At least the Docker part. I don't think I have any bare metal stuff around. But now I also understand the reference to Equinix Metal, because this is bare metal, and I think it makes it super easy for, I don't know, larger enterprises or mid-size enterprises. They have something which is bare metal, and they boot it up, and it's just there. And you can even, like, if you're using IPMI or something else which mounts the ISO, you get it up rather easy.
Yep.
of whatever is the modern stuff from bare metal provisioning. I don't know, but in the end, it's a cool way. Interesting.
Yeah, actually, we have a whole product called Cdero, which builds on top of Cluster API and basically does automated provisioning of Talos. And we use IPMI to do power management of all the nodes, and it bootstraps Kubernetes clusters for you on your bare metal. It comes with a iPXE, PXE, TFTP service, a service for Talos to get its metadata from, and it's just a nice way to kind of manage your bare metal infrastructure. In fact, it's all just Kubernetes CRDs at the end of the day. We call them servers. These are servers that are registered, and they're within this pool for Cdero to create Talos-based Kubernetes clusters. You just say, I want a Kubernetes cluster that is made up. We have this idea of server classes. The output's a little ugly. We need to fix this. Server. No. Really? It has servers, but not server classes. I'm probably fat fingering something. Anyways, we have this idea of server classes, and basically what that means is you can have these things called qualifiers, which say, you know, anything that's a super micro motherboard with this type of Intel CPU and this much RAM, so on and so forth, this is a T2 micro within our data center. And then you can tell Cdero, I want a Talos-based cluster that is made up of 3 T2 micros for the control plane, and maybe you have another server class called an M5 large or something. I'm using AWS instance types. And it will go and create a Kubernetes cluster for you based on these server classes, manage installing Talos for you, manage the power cycling of the machines for you, the bootstrapping of Kubernetes, and you get bare metal Kubernetes clusters. So yeah, really just all that to say, yes, Talos really does make bare metal a lot easier than traditional operating systems. And circling back to the local cluster, oh, I know what happened. Sorry, go ahead.
I wanted to ask about Cdero. Is there a website, or how is it pronounced?
Yep. Cdero.dev, SIDERO.dev. So we didn't get server classes because when the CLI creates the cluster, it's done. It basically sets up your kube config and Talo Ctl to speak to it automatically out of convenience. So it switched the context out from me, but here's what server classes look like. We have a general, medium, x86, and I have 1 that is available and 3 that are in use currently. But if I go back, Talos Ctl version, Talos Ctl should be, okay, I know what's going on. Config endpoints.
And another quick question.
Sure.
Around RISC-V, which I've seen at KubeCon EU, as like an environment to run Kubernetes on. Is that something Talos can do as well, like installing it on a different architecture than x68?
x86 64. Yeah, so currently we only support x86 64 and AMD 64, or sorry, ARM 64. So you know, spinning up Talos on a Raspberry Pi, we have actually pre-made images that you just flash to an SD card, turn it on, and then Talos sits there, waits for the config to be pushed to it, and then you have yourself a home cluster a few minutes later.
Perfect. So for example, if I would want to use the AWS Graviton, this is ARM-based, I think. Yeah, this should be possible as well.
Yes, absolutely. Yep, we've tested that, and that absolutely works. So just circling back, you can see I created a Kubernetes cluster. It's right here running in Docker right now. If that's too small, let me know. But you can see I have 2 Talos containers running, and these represent my nodes right now on my local laptop. So this is a great way in CI/CD, for example, like we run Talos, and you know, obviously for our Kubernetes clusters and CI/CD needs. And then on top of that, we're actually spinning up Talos within Kubernetes as containers and testing basically creation of Kubernetes clusters. And this is a great tool for even like, you can give your developers Talos Ctl, they can spin up Talos clusters that have the same version of APIs, based on whatever you're running Talos, whatever version you're running in production. Say you're running 0.10.3 Talos in production, you just tell them spin up a 10.3 cluster with Talos Ctl, and you can get an environment that can mimic, at least API wise, maybe not kernel wise, your production environment. You can set it up to do QEMU, but that's Linux based only. So you can get a little closer to emulating production. You can set this up in CI/CD. So it's really a great development tool, and being able to bridge the gap between developers' environments with production and testing and staging and so on and so forth. I'm going to destroy this one.
How does the authentication work? For example, I have 10 Talos clusters.
Mm-hmm.
How is it like Talos has a config, like the kube config, let's say?
Yeah. So
or does it use even the kube config?
Yeah. So it well, I can't see my screen because of the. There we go. What is it? Talos. Yeah, we have this. It's kind of like Kubernetes .kube/config. We have a Talos /config, and this contains all the PKI that you need in order to communicate with the node. And in 0.11, what we added is RBAC. So we have 3 different roles right now. We have a reader role. We've kind of decided which APIs are safe for reading, like getting network addresses, interfaces, so on and so forth. These simple things, but like upgrades and resetting and destroying a node, that requires the second role, which is admin role. And then we have a third role, which is an etcd backup role. So with Talos Ctl, you can actually perform etcd backups and recover from them. And so there's some people that are creating controllers, and the idea with, going back to this cluster API and Sidero thing, we can have a controller that actually does automatic snapshotting of etcd, pushes it up to an S3 bucket, and then you can go ahead and completely manage etcd. And so yeah, that's the API. I want to show you guys one more thing too that I think is really cool. We are working on a UI. Someone mentioned a UI earlier.
Yeah, that's always me. I'm used to automating things with APIs, but I also know the need of a dashboard or UI for
right
to also at a certain point sell it to your internal teams.
Yep.
Just to say, hey, it's not just a terminal and an API. It's something where you can click, where you can create your own workflows based upon.
That's exactly what we're learning. And that's why we're building a UI. So this is I'm basically looking at that same cluster. You can see here's the node that I messed up. It is not ready. And so now I just gave myself some work for the day. I'll go fix that after this. But if I click on one of these nodes, right, remember the Talos Ctl Dashboard. This is not completely like Talos Ctl Dashboard. We're still working on this. But again, this is just like the first thing I showed you, where it's instead of being TUI based, now it's just web based. And this is all data being pulled from Talos. And so nice, pretty little graphs, API driven. I can get a list of services. I can get the kernel logs. So really nice to have that. That's very, very handy. Logs for, say, the kubelet. These are all things you can do, by the way, with the CLI, but we are working on just pointing out that we have this, UI that we're working on. So list of pods that are currently running. And then going to what we were talking about earlier with Sidero and how Talos makes, bootstrapping things easier on-prem. You can see that I have a cluster that I've created. I have a list of servers. You can see this is a, accepted. Is this? Yeah, it's in use currently. something's wrong with this server. So yeah, just pointing this out because we are working on a UI. I'd even be able to switch context here. Can I? Yeah.
Can you show the graphs again?
Yeah. Let me click on this one.
Nice.
Yeah,
Screenshot
no,
time.
this isn't Prometheus or anything. This is just APIs from Talos.
Yeah, I think it's great because you don't need to like always use Grafana or custom dashboards when you can just show, use current technology to show a graph and also provide inputs on like correlating something or immediately seeing when there's a spike or when there's like something going really wrong.
Right. Yeah, it's actually interesting that you bring that up because one of the things that kind of is the vision here is that now that we have an operating system that has an API, we have an orchestration system that consumes that API and also provides an API. We have metrics, we have data. We can push this through almost like a if this then that type system for your infrastructure. Like, for example, I remember running Kubernetes and there was a version of Docker and there was this weird plague unhealthy error and there was no resolution for it other than being woken up at 2 a.m. in the morning and restarting Docker. Now imagine you can set up some kind of, piping system where you can consume this data, maybe particularly around the Docker daemon, just using that as an example that says, if the memory, balloons up to this threshold, use the APIs to automatically restart the system. Doing something like that over SSH or Ansible Tower, all these things, like all the tooling that we currently have just sounds not fun. Where in this world, we can have a controller that actually lives in a management plane somewhere, which can consume all this data and we can run it through any kind of processing that we want and just use APIs to restart it for us instead of waking up an engineer.
That's really great and brings me to an idea of saying, hey, you can do it like on your own in Talos, but you could also plug it into Prometheus and the Alert Manager, for instance,
right,
and use what's possible already there. So people are already like used to PromQL and the alerting rules and like maybe even defining annotations in Grafana. And if you plug it in and provide a channel back to say, hey, I just want to do create an event which automatically restarts something, and I don't want to do SSH and service whatever full restart, but instead just calling an API. And do I get immediate feedback from the API? Possibly. And on the other side, if you have an API, you could write or create something like an event stream. So where you can like subscribe to something and consume maybe the logs, for example, or something like that. So I've been building that in the past for monitoring systems. And oftentimes I was asked, like, can I just get an API which dumps a JSON file, JSON line with an event every second or whenever something happens? And can you also buffer that? The buffering is the separate point. But in the end, it's like, I want to consume it live, and then I need to write my own API client, or I use a different system, a daemon.
Yeah.
And when you provide that to users, they start adopting it even more. And then it's like the self-marketing of, hey, everyone talks about it because it has consumable APIs.
Exactly. Yep. I mean, it's really just it's kind of what operators in the Kubernetes world has done for deploying applications and managing them, right? You just submit a CRD and this happens. I mean, and you can make decisions based on events, so on and so forth. Same idea, but we want to bring that down to the operating system. And we do have events, and I'm trying to show them to you.
So I think we have to invite Andrew again to show us Sidero.
Yes, I would love to show off Sidero. Yeah, I don't know what I'm doing wrong. As you guys could tell, I'm becoming a true CTO, or I'm becoming less and less. I don't know what I'm doing wrong.
Resolver error. DNS problems. Hmm.
Oh, good. Oh, we have Michi here. Come on.
Yeah, the thing is, debugging a black box is oftentimes, so I'm not really used to the system. I'm just trying to understand name resolver error produced 0 addresses.
I think
so
I know.
You're getting an NX domain right now, or a surf fail.
Yep.
Or it's just
it's probably not
missing a
resolving
record.
these. Config use context. Let me jump back over to this node. I would just use the IPs instead, I think.
So Sean McCord, I think he's from your team. He said DNS name, exclamation mark.
Yep. Something happened with DNS there. It was working, but you know, anyways, I switched over to using the IP addresses, and you could see everything in Talos, going back to what you were talking about, Mikhail, is we're trying to publish as an event. And the idea is that you can make decisions based on those events, consume those events, and maybe you look for particular events and make a decision based on that. So for example, you know, we set the R limit here. We, you know, started container D was stopped, so on and so forth. This is any event that really happens within Talos, you can actually subscribe to that. And that could be your way of consuming, you know, what is actually happening and making decisions, right? Coupling that with APIs like give me the list of addresses, right? There's all kinds of things that you could do.
Yeah, and one thing we also did in the past was to add a simple filter in a way of saying, hey, I want to get a specific event type, or I want to get all messages where this string is inside. Doesn't need to be a regex, can be just a wildcard pattern or something.
Yep.
So that you don't need to consume the whole network traffic, but the server filters for you a little bit.
Yeah. Even you know, going back to Cozy, and we have this idea that we're going to be namespacing resources. So the whole networking namespace, maybe your networking team just wants to get events related to networking. So you can say, give me all events related to networking and filter on those, right? There's all kinds of things that we can do here.
Yeah, one of the ideas we had, but it never got implemented, was sort of defining queues where you have multiple subscribers for, and those queues can like buffer specific events. And when you connect at a later point, you get the backlog. So you never lose something which you might be needing for SLA reporting or for your persistent logs or something else in that regard.
Mm-hmm.
But on the other side, it is an advanced feature. So at first glance, you want to make it happen, and then you look for feature requests and how easy it is to maintain, and how much performance impact it has when you're adding buffering all the time.
Exactly. Yeah, this is all we keep a in-memory buffer of X number of events, and you know, eventually it's a circular buffer, so eventually it all goes away, but you can look back into the history. And that's what I'm doing here. That's what this tail -1 is doing.
Maybe, Redis might not be the best idea to buffer lots of things, but if you're running out of like application memory, storing it in Redis.
I mean, it could be maybe this is something optional, right? You can run Redis in Kubernetes and maybe expose that and tell Talos to use that or something. That's, you know.
But in the end, it's a user space. So the user should be able to subscribe to the event stream and then store it or cache it in Redis for later repurposing. So it shouldn't be your task.
Yeah. Our goal at the OS level is to really give you the tools and APIs to make these higher level things possible. What you're talking about could be written as a controller within Kubernetes, and then you just use the Talos APIs to consume that. And, you know, we want to keep the operating system, again, going back to the very first thing I talked about, was Talos is ultra minimal, not just minimal. It's just what you need to run the kubelet and our APIs, and we want to keep it that way. but we also want to make the APIs powerful enough to where you can do these more advanced things with external controllers.
I think that builds out a great storyline. So you have Talos as the operating system, and then the user story is, hey, you can like add a controller, you add Redis, you add, I don't know, Grafana, Prometheus, whatever is needed around it. And when you have these stories, you can write blog posts for like reaching greater visibility. And also have these like the use case stories, because right now I'm learning as we are talking what Talos is and how I can use it. But I also think that others might want to learn how exactly it fits, or what you can do. And when you mention like, oh, it's like easy logging, I think logging always implies that you need to have Elasticsearch or Loki or Fluentd, whatever. So like the whole ecosystem attached to it, and you dump something in there and it's hard to find it again. Maybe like when it's coupled with Talos on a simpler level, just to see the events or the logs events, basically the same. Diving even further into like observability topics like tracing, or distributed tracing is super hard in my opinion, especially when you need to do it on the application level as a developer, learning new things. But if there is like, maybe me dreaming, it's an OS which provides me with an API, and they say I'm just sending it over there, and I don't care what the OS is doing in the background. This would be an interesting idea.
Yeah, exactly. I think you get it, Mikhail. There's an API-driven operating system really just opens up a whole new paradigm within Linux distributions that I think we're just barely beginning to tap into. And it's taken us a while to get to this point, because again, we have rewritten the entire user space from scratch to be controller-based on a modern language, Golang, and with Kubernetes type ideas into it. We're not taking any shortcuts. And so, we've gotten up to this point, but all the things that we're talking about, I think is going to take a wider, broader community, which is why I'm happy to get on, things such as this. And we just got to spread that word and let people know that, there is a way that we could do this better in the future, I think. So I think you get it. We got to get there. And Talos, I think, is a start to that. And that's why also we're trying to push very heavily for the common operating system interface, because we want this to be an industry standard. We want to agree on what the protobuf definitions should be. When I apply this YAML file for configuring an interface, it needs to be able to have all the options, and we all need to agree on what that looks like and feels like and how it behaves. And so, yeah, we're really trying to bring this even beyond Talos, but trying to make this just the way that we're headed, API-driven operating systems.
In the Cozy project, I think I pasted in the chat. How is Chris Nova involved? Is she working with Talos? Are you collaborating on the project?
Yes, she's sharing a lot of great ideas on Cozy and advocating for it. And she's at the Cozy meetings regularly. She's a big part of it. And she definitely gets the vision. We were just talking about it this morning, actually. And, we think it's going to take a while, but it's the path to go for sure. And, our meetings are, we're kind of using Talos as a playground right now for Cozy. And I don't say that to sound like Talos is not production ready, but we're proving out the theories. Whether or not Cozy evolves and does become this industry standard that we hope it does become, that's, we'll see. Talos itself, we believe in these ideas and we will continue doing that. And yeah, Nova is very much behind this.
Are the calls, like the weekly calls, open to community? Can everybody join there, or how is it?
Yeah, so the Talos community, we have a call every week. I'll stop sharing my screen. We have a call every week on Mondays at 16:30 UTC. It's on, if you go to the Talos, github.com/Talos-systems/Talos in the README, you could see a link, get a link to our community calls. And Cozy itself also has one on Wednesdays. And if you go to github.com/cozy-project/community in the README, there will also be a way for you to join the party.
I think Chris Nova had one of the best appearances in Clustered series.
Yeah, so I was giving my presentation that day and I only got to catch a little bit of it, but that was a fun one.
Yeah.
I don't think I'll be able to live up to it tomorrow.
Yeah, you can top it.
I want to do one with Talos as the base. Sorry, go ahead.
Yeah, I think the Cozy project, also when you have to rename it, I think, I also think it's the future.
Yeah.
So I believe in it also now. I'm a believer.
Great. Converted you.
Yeah.
Okay, so I'm expecting that Philip will be doing the next live demo based on Talos.
No, we invite Andrew.
I can sit there and watch you fumble with it and provide guidance.
Yeah, but today I learned that I can just Talos create cluster and run it locally. So this is really great. I did not know that.
Really? Yeah, we got to do better, I think, about showing that off.
Is it new?
No, this is actually one of the original ways of creating Talos clusters. Like getting Talos installed on anywhere else was a nightmare. And so we were just, okay, how do we actually get people to try Talos? How can we test Talos? And so we made this Talos Ctl cluster create command. It's like a kind, right? Or Minikube, but it's Talos.
Okay. So as I embarrass myself, I will be quiet now.
No worries. I was actually like following Talos.dev for the project website, and then I clicked on like try now, and the quick start tells me what to do. I was just curious of like, is there a different way, or is there like the live demo way of actually doing that? So that's really nice. And I also like what I see on like the UI level, on the API level, and also the vision. If I have the time and I want to start contributing, do you have sort of issues which have like the good first issue label on it, or how would you like encourage someone to contribute?
Yeah, we certainly do have those. We could obviously, as with all projects, do better about labeling them. But I will say that Talos is a quite low level. And so it could be kind of a big undertaking to kind of grok on your own. But we have a very, very good community. So if you go to our Slack, again, that's in the Talos README, and join our Slack. The community I'm really, really proud of our community. Everyone's super helpful. We talk in the open a lot about engineering decisions. Again, the community meetings are a great place. Just come and talk to us. I think that's the best way. If you're not getting, a concept, we're always happy to hop on a call, and chat through some of the ideas, get opinions on things. There's a lot of people in our community that influence the direction of Talos. And that's what we're actually pride ourselves in, is we try to be data driven, ask our community, what do you guys want? And go and make that happen. And we have people that are contributing very big, significant things to Talos, but it does have a little bit of you'll find that, even just using Talos, there is a learning curve. And this is something that we hear consistently in user feedback stories, is there's a learning curve, but man, once you get past that, it's really just changed the way that we look at our infrastructure. Obviously that's the user, and you're asking about developers, but the point is Talos does have a learning curve, even, translated over to the development side of that, because it's not your typical, simple Go application. We're writing a completely new user space. Everything's controller based. So yeah, come in and just talk to us and join our Slack, join our calls, and we can get through it.
Yeah, we'll quickly share my screen so we can like what I have opened now, and this will also be linked in the blog post later on. But I just figured that the documentation is huge. It's really inviting. We have lots of guides how to install it. The introduction provides the quick start guides, which we just talked about, and following up the getting started, what to do next. So yeah, it will be like tried. I would encourage everyone to try it out and follow the documentation. Join the Slack channel, and I think there is a discussion board as well. And I've also seen that there is like learn more with the philosophy, the concepts, and the architecture, which also should be helpful to get things going. Since you mentioned that it's like low level, is there some books or some courses or some presentations you maybe recommend in watching or getting? This is something which could be added to the docs as well, but it's just me asking now.
Yeah, that's a good question. I have a horrible memory, so I'm sure I've learned from a lot of really great resources, and I'm not going to do any of them justice. And so I won't attempt to say any particular book or whatever, because I really, I think Linux experience is obviously, crucial, fundamental, understanding, how Linux just fundamentally operates. One thing that actually helped me a lot, and this is not as simple as reading a book or reading a blog, but Linux from scratch really just kind of really takes you through how a Linux distribution is built from the bottom up. And it really just kind of is eye-opening. And for me, that was very cool. But it's a lot of work. Trust me. Linux from scratch, you're going to be compiling a lot of things.
Is it a distribution of?
You could call it a distribution of sorts, but it literally takes you through like, okay, let's start with a host system, and now let's build GCC and bin utils, and we're going to build this in some special phase, and then there's like a phase 2 building it so that you end up with a tool chain that's completely decoupled from your host system. So all the linker search paths and all these things are as pure as possible from any host operating system. And then you use that to actually build your packages, which will make your distribution eventually. So you're building, Flex, Bison, GCC, bin utils, elf utils, so that you can end up building bash, and then so that you can end up building IP tables and putting that all together into an initram FS. And, it takes you through how do you literally build a Linux distribution from scratch.
Interesting. So it's even more raw than I would be using Gentoo, for instance.
Yes.
Which provides more abstractions to it. Interesting.
Hard to believe, but yes. Gentoo is more abstracted than LFS. Yeah.
I know some portions in that regard, but I never took the step myself of saying, hey, I'm compiling my own Linux now. But it's really interesting to learn and see how it goes, or how it actually works in the background. It also helps you with debugging.
Exactly.
And sometimes when grub is not working for some reason because Windows overwrote the boot partition for some reason, then it's like you should be knowing how it works, or at least know how to Google it, because from the error, it's
exactly
interesting. But let me link that Linux from scratch in the blog post later on.
I think on the 28th of July, we have some time. You can present this to us, Michi.
Oh, yeah.
No. On July the 28th, we agreed on the Helm registry from GitLab and the Terraform registry, and this is work for you.
Good. Good for you.
Yes, this is actually a good idea. try it and see how far we can go in 1 hour. No, it won't take 1 hour. It will take the whole evening.
Oh, it takes a while. Trust me. You have unless you have a really fast computer, which can compile things quickly.
Let's do it in the cloud and get the biggest instance in AWS, which still, compiling is taking quite long. And XKCD 303 is my favorite for that. Like, why are you slacking off? Because I'm compiling, or because GitLab is down, or whatever.
Right.
But yeah, I think many years ago, when I was in Vienna at the student storm, a colleague was compiling Gen 2, I think. And compiling the tool chain took 1 day, and compiling the operating system 3 days or something like that. So it was in 2005, where we didn't have any like multi-core CPUs back then. So it took a while, but in the end, I think it's great to to sometimes dive a little deeper into all the stuff.
It tells the story of, like, I studied physics, and I had a choice. Do I want to study physics, or do I want to do computer science? Well, I should have done computer science, but I decided to do physics because, to me, engineering is the how, and physics kind of explain the why. And so I think when you dig deep into, something like LFS, like literally building something from scratch, you scratch that itch of why was it done this way. And, I think that helps you do the how better.
That's true. I just spotted a typo in the docs.
I'm sure there's a lot.
Yeah, the problem is I'm spotting that all the time. No worries. I was wondering where the docs located to contribute.
They are in the Talos repository in a directory called website, and then there's something called content underneath that.
I was looking in the docs folder and wondering why it's empty. The thing is, or this could be an idea for making contributions easier, to add a link to each website and say, hey, you can edit this website on GitHub or in the repository.
Yeah.
To make it more discoverable, and allow everyone to like fix a typo or suggest a grammar mistake, suggest a better documentation. That's what I wanted to say.
Yes, that's fair
because
enough.
when I see something, I want to fix it. I don't want to ask you. I don't want to send you an email or whatever. I just want to fix it, propose the change, and then continue.
Yes, that's fair enough. Noted.
I could also open a feature request for that.
Hey, yeah.
No, just push it to main. It's okay.
Yeah, no, I spotted Kubernetes instead of Kubernetes.
Oh, wow.
Somewhere.
There was a discussion on Twitter last week or something. How many of you spelling Kubernetes wrong? And I always like Kubernetes is also
that's a common misspelling.
Kubernetes. That's I always write Kubernetes. Then the person said
L instead of a K.
Yeah, so maybe they said that's why they invented K8S, so nobody has to make any mistakes anymore.
I don't know. I think like one of my problems with not being a native speaker is acknowledgement, how to write that correctly, because I need to remember that it's like the D and the L and the E, acknowledge. Yeah.
As a native English speaker, there's a lot of words like unknown. I always spell that wrong. UNKONW.
The problem is with an acknowledgement in the monitoring system I kept developing. It was like the common thing, you acknowledge a problem. And it's like, oh, not again, I made a typo. And yeah. Anyhow, I think I don't have any questions anymore. except for that we want to try it out, and Philip wants to prepare the next session.
Yeah, sure. Yeah, I mean, I was so stupid to make Talos running on my Raspberry Pi cluster, while instead I could just run Talos create cluster and then have it in my Docker. So,
I mean, just to be clear, that's a like local development quality one. I wouldn't run anything serious on it. Oops.
No, but
but
I did it on Raspberry Pi. It was good, and
I think when you run it on the Raspberry Pi, or I'm also reading Pi and 64 and Banana Pi and other things in the docs. It has this like hobby playground a little bit, at least. It's not your work computer where you're sitting in front of all the day. It's something somehow like I build Lego models. It's something like you play with a little more.
It's really fun. I mean, I have a Rock 64 in my closet and a Raspberry Pi, and from there I use that to run like AdGuard, and I run Cedero actually to manage other clusters within my sorry about that. I run Cedero. I run Cedero in this Raspberry Pi cluster. It runs on ARM, and then from there I'm managing a bunch of other bare metal clusters within my closet. So it's pretty fun to do.
Okay.
Interesting. Now a question around like roadmaps and obviously pricing and money, and how you're like building a sustainable model in the future. This would be my question of like, what is the enterprise offering? Is there an enterprise offering? And like, how does it work for you?
So first and foremost, we are committed to keeping what we do open source, 100% open source. The way that we make money is off of a support model and professional services and stuff like that. We're doing well with that, and it changes based on the customer. I'd say the pricing model, but we do have a basic, here's how we do it, and it's basically based on per cluster. And our idea is that really the risk is in sorry about that. The
risk and the number something in the kitchen.
Yeah, someone's in the kitchen. Yeah. The risk is in the control plane for us, really. Since Talos is immutable and all that good stuff, adding worker nodes, it's kind of, it is what it is. It's simple. It's simple. There's not a whole lot of issue there. Really, it's protecting the etcd data. And so we have a cost per cluster, and that comes with 20 nodes. And that doesn't include the control plane nodes. So you get 3 control plane nodes or however many you want, and then plus 20 workers, and that comes at a base cost. And then per 20 after that, you pay not the price of the cluster, but there is an additional price per 20 additional nodes. And sometimes that doesn't work for people, and we come up with a different model, especially when the scale is really big. And we kind of get creative with it, but that's the rough idea there. We do have an enterprise offering, but we're not really looking into having like enterprise proprietary software that's binaries that you can't download for free. We are, open source nerds at heart. So that's a big part of our personality, our business cultures. Open source is very, very important to us.
That makes me happy. Thanks. Is there anything you want to share from what is coming next, or is there like at the top of your head where you're speaking next to get more insights? I would totally love to have you like in half a year or some months to have you back, sharing your latest and the greatest.
I would love to.
We talked about today, features.
Yeah, we're working on a project that we're calling Argus, which is basically it's going to be a big abstraction on top of Cluster API and Talos that's really going to move closer towards this vision that we were talking about earlier, where, you know, completely automated upgrades, you know, this if this then that type thing, you know, providing this ecosystem for a more living, breathing system that's reactive rather than waking up humans and doing it. And it's called Argus. And again, we're building it on top of all the things, and we're working up to that. So I'd love to come back and talk about that when that's a little more fleshed out. Yeah, I don't have anything on the schedule to talk about Talos after this. Tomorrow we're going to be on Clustered. That'll be fun. I'd like to give them a plug. That's a fun little project. So yeah, just you know, we're heads down right now. Really, we're a very engineering based team and technology driven. So, you know, we're all heads down building out this stuff because it's a very ambitious thing, but we're making really big progress. So happy to come back in 6 months and show you what we've done in 6 months.
Perfect. Thank you. Okay, then I would say let's wrap it up for today. Thanks for taking the time and also exceeding it a little of talking endless about interesting things.
No problem. It was fun.
Thanks to everyone who was chatting on the YouTube stream as well. Yeah, and we will see each other next week for CyberCloud. This is the spoiler. And until then, I would say thanks for listening. Thanks for watching, and bye-bye on YouTube.